Hi class, let's see what's dynamic arrays. So before we talk about dynamic arrays, we will talk about dynamic variables because the two concepts are very similar. You've seen the video in pointers. This is the exactly same code. So we declare a pointer called p, which is an integer pointer, and then we allocate a memory for an integer. And here is just a regular variable. So what is a dynamic variable? A dynamic variable is a variable that is created dynamically at runtime that use the keyword new. So the dynamic variable is not p because p is actually a pointer variable. I would say that where p is pointed to, that memory space holds a dynamic variable. And sometimes it's called ordinary variable in comparison to dynamic variable. So what is dynamic array? You can see the structure of using it is very similar. So we declare a pointer first to actually an integer. And then when we create using new, we use in and then follow by square bracket and the array size. So that's how we create a dynamic array. What it does, it will allocate, for example, if size 3, it will allocate 3 spaces for the integer, or 3 integers, right? So the power of dynamic array is that we don't need to know the array size until later. So you could have created this pointer sometime earlier and then use new to create the array a lot later on. The array is used like a regular array, but one thing before I go to the demo is to point out that you can see p is actually pointing to the first record of this array. So to play with, if we look at the 3 lines of code, is exactly the same like is in the PowerPoint. To use the array is very similar to just a normal array. We use the pointer p as just like the name of the array, and then use a square bracket and hold the index. And so here we assign the value to 1, 2, 3, which is 1 plus the index number, and then we print it out. And so what do you expect will happen then, right? I need to compile the program. So you can see that it prints out as 1, 2, 3, just like a regular array will do. Is just p bracket and then I. This is how to use an array. Another thing I want to mention is that you can actually do something called type def. Type def is to define a new data type. And so here we define a pointer, a integer pointer, as a new type. And that's why earlier in the last video we talked about you can have int start, because you can also do int start p where the start is close to the integer to declare a pointer. So here we make this a int pointer new data type. To use it is very simple. You basically replace this int start int point to by int pointer, and then do np, and then everything else is exactly the same. I can show you in the program as well that this works, I guess. So if we run the program again, it gives you exactly the same result. So now want to point out that actually you can do pointer math. You can do increment or decrement, use the operators to increment the pointer to the next record. And so the compiler is very smart. It not only increment one bit, but it actually increment to the next record because it knows what kind of dynamic array it is. So here the P0 is equal to 1. And so when we do plus plus, but in front of the array element, it actually increment the pointer P to point to the next element, which is P1, which has the value of 2. And that's why 2 is printed out, because we do it ahead of time, right? And now actually P0 will be, basically the pointer is pointing to P1 as the first record. So if we look at this in code, right? Or how about let's change this to plus plus 2 afterwards. So we would expect that actually it will print out P1 at P0 first, which is the value of 1. And then P0 will actually, in the second line, it will print out the value of P1, which is 2 then. So you see right now it print out 1 and 2. So the last thing I want to, or the next thing I want to discuss is using delete to delete the array, the memory allocation that was being done for the array. Just like in the last video, it's not deleting the pointer itself, it's actually just deleting the memory that's being allocated by the pointer. So P is now undefined, just like before, uninitialized, and it can be reused. Actually, in both cases, when we do delete P or delete bracket P, or if we declare a pointer but we are not going to point to anything yet, a good practice is to set it to point to null. What it will do is, if you accidentally try to do something to dereference it, it will actually give a good indication that you are not supposed to do it. Instead of, it might accidentally give you a result that was a random result, and you might continue to do the calculation and you didn't know about it. And so it's a good practice to put to assign P equals to null when you don't when it's not pointing to anything. And so you see, even though it's at the end of the program, I still do it, and a lot of people would argue that that's a good programming style. So this is the end of the discussion for the dynamic array. We would not have a video about the next assignment, because the next assignment is actually a repeat of the sum and average of our, I believe it's lab number 2. But in this case, you would use an array to collect the input from a file. But the calculation is basically exactly the same. So I hope you enjoyed this video, and I will see you next week.